Ahead and get started. Thank you everyone for joining us to another PAVE virtual panel. My name is Tara Andringa and I'm the Executive Director of PAVE. And we have two panelists joining us today, Mr. Kevin Mills, the Associate Director for Ground Vehicle Robotics from U.S. Army DEVCOM Ground Vehicle Systems Center, and Ms. Ann Schneider, the Director of Defense Unmanned Ground Systems for Robotic Research. Welcome to both of you.
Thanks you for having us.
Thank you.
So for the last year, we have obviously held virtual panels at PAVE, and we've tried to cover a wide variety of topics, but all of them have involved public roadways in some way, and either talking about passenger vehicles or trucks and freight. And for the month of June, we wanted to do something a little different, and we are taking a look at applications of AV technology in different industries, looking at things like construction and mining and agriculture. And this week, we wanted to have a conversation about AV technology in the Defense Department and how it's being used in national security, which is probably the biggest user of AV technology in the country. So we thought it was an important thing to touch on. Super excited to have our two panelists joining us today. Kevin, I want to start with you. Can you just give a little bit of background about the Ground Vehicle Systems Center and what it is that you do there and sort of how it fits into the larger DoD ecosystem?
Sure. So it's the Ground Vehicle Systems Center is basically the R&D portion for ground vehicles for the Army. We work under the Combat Capabilities Development Command, of which basically the labs across the country are organized in terms of providing that science and technology research and development focus for various, I'd say, domains that the Army focuses on, lethality, communications, aviation, soldier, and then the Ground Vehicle System Center, which is ground vehicles where we focus, and ultimately, our facilities in Warren, we're located at TACOM, the Detroit Arsenal, and we work closely with the Southeastern Michigan local community for the bevy of talent within the engineering space. We grew out of the arsenal of democracy there, where in World War II, a bunch of the commercial automotive industry really pressed into service for to support the war effort, and really the decision was made there that we need to have a continuing presence, and we're really the offshoot of that continuing presence in local region, and we're grateful for the support we get from the community.
Great. Yeah, and I was going to say, it's obviously no coincidence that you're located in the heart of the U.S. auto industry. And kind of at PAVE, one of the main things we talk about is collaboration. And what our group does is bring together the public sector and private sector and academia and nonprofits with the belief that we will never reach the potential of this technology unless we have all of these groups working together. And sort of what I thought was interesting about this conversation is bringing together, some work that's being done in the, industry and in government. And on that note, can you talk about robotic research, what it is that you all do?
Sure. So I always like to say robotic research was doing autonomy before it was cool. So we were founded in 2002. The two founders were actually working for the government at the time. They worked for the National Institute for Standards and Technology, doing a lot of the really early ground vehicle robotics work for the Army and the Demo 1, 2, and 3 programs, if anyone here is familiar with those. And when they decided to spin off their own company, they continued that is kind of their main focus, at least at the start, on-road and off-road autonomous mobility, and also kind of, I'm going to call it autonomy enabling technologies. So things like localization, critically important to being able to drive robotic vehicles in GPS and GPS-denied areas. So, throughout our work, we've also created a suite of localization products, both for ground vehicles, but also things like aerial vehicles and dismounts, like dismounted soldiers. So over the years, we did a lot of work on autonomy for a wide variety of different government organizations, a wide variety of platforms. We were able to deploy some of those in theater as well. And over time, we went from kind of automating single vehicles for, let's say, a route clearance automation effort to more advanced AI to actually control teams of vehicles. So we're currently working with Ground Vehicle Systems Center on a autonomous logistics convoy project. So obviously having a team of vehicles that are coordinating in this logistics effort, but also things like manned, unmanned teaming that we do a lot of work on for the special forces as well. And probably about 5 or 6 years ago, we were able to take a lot of this expertise that we had gained on the defense side and start up our commercial systems division as well. And there's really a lot of synergy there. So we've partnered with a lot of OEMs, such as New Flyer, who's North America's largest bus manufacturer, and Local Motors, who creates the Ollie shuttle. We do the autonomy kits for, now been deployed on something like 4 continents. But we've been able to take some of these hard problems that are kind of more defense related and even bring those to the commercial market. So we've recently partnered with FP Innovations for a Canadian forestry and logging convoy project. And the type of roads that they drive on, even though that's a commercial application, are much more similar to the kind of secondary roads that our military convoys have to drive on. And that synergy kind of goes both ways as well, because all of those deployments and the economies of scale you get from the commercial side are also feeding back into defense and allowing us to get cost savings on the government side being driven by the commercial market. So, really focusing on both of those efforts, although today, obviously, we're going to talk more on the defense side.
Yeah, for sure. Although that is one thing I want to get into is sort of some of the lessons that can be, learned from one application and transferred to another. Kevin, I'm curious if you can talk about just sort of in a, big picture, what are some of the roles that the Defense Department is looking to autonomy or automation to fill?
Sure. Yeah. No. There's quite a few, and I'll avoid the aviation and I'll focus on ground because that's where we focus. But it's there's fielded systems and explosive and ordnance disposal or EOD missions. That's fielded systems today and across and that really remote control vehicles, smaller systems from something you could carry to something that maybe 2 or 3 folks could carry, it provides a standoff distance, but it requires basically a person or even a team of people to maintain and to operate. And it's really a burden on the system. So it only works in those missions that are so dangerous that go dispose of a bomb. You want a robot to do that. Right. But where autonomy starts to branch out and systems start getting larger is where we start looking at the squad offloading system, the SMET or squad multi-purpose equipment transport. That's now about the size of an ATV. Soldiers can offload equipment onto basically a flatbed vehicle. That's in the final stages of being fielded. And once you have that system that large with a flatbed, now you can start adding payloads. So you can start looking at more military relevant missions. Adding weapon systems, adding smoke, adding construction equipment or route clearance or even missile systems. There's a strong bevy of options that you have once you have this flatbed mobility system out there. Building on top of that gets into robotic combat vehicles. So that's systems now made to fight in and among manned systems as wingmen. The concept is manned unmanned teaming, and again, a lot of the same precepts of the smaller systems, the ability to be modular and add different payloads to a mission, really expands the envelope there. On the tactical side, and this is where we work a lot with robotic research, is in convoys and how can you get folks out of those dangerous missions. If you're at all familiar with the Iraq and Afghanistan wars, a lot of folks were taken in. They don't attack you where you're strongest; they attack you where you appear to be weakest. And so, getting people out of those convoys that form those logistic lines is essential way to take out some of those insurgents tactics, which really lost a lot of American lives and equipment. So we're starting. The approach we take in all these is you start with the easiest problem you can solve and get a capability out there. We're using leader follower as kind of that where the manned system proofs the path, and then you have robotic vehicles almost like virtual train cars behind it to be able to start offloading a lot of those folks from that task and being able to put them on things that only humans can do. That capability, while we're demonstrating on the PLS truck, could be applied across any autonomous, convoy type vehicle, and even applies a lot to the long-range precision fires mission space, which is maybe not as I'd say mission intensive or intensive on the autonomy system as the direct fire systems, because there's a lot more standoff when you're launching artillery shells or long-range missiles. But the big concern there is counterfire. Once you fire, you've given away your position, and there's the enemy can interdict, but you can shoot and scoot is kind of so it's shoot then move, as opposed to shoot and move at the same time, and the reaction times aren't quite as intense, and the mobility requirements are a little bit less. So it's another area. But effectively, all elements of ground vehicles in the future will probably start to see automation of all the tasks. If we can do it right, leveraging what's going on in the commercial industry and what's going on within the government, those are the tasks we can start to offload from the soldiers and the vehicles. Let the vehicle take care of the driving, and have the soldiers do the commanding. And making decisions and using intuition and using their experience, things that maybe someday some future AI will be able to do, but those are the things that are really hard, that a human does intuitively and through training and experience. Let's let those focus on those missions, and then leave the driving to the system. And that's a way we can start to reduce crews in vehicles in the future, but ultimately get the crews out. I mean, that's the goal. And so it's a wide swath, but all the way from the smallest systems up to the largest, we see there's a function of autonomy. And so that's why we're putting so much effort in this space.
Absolutely. Anne, I'm curious if you can talk a little bit about the collaboration process. And sort of what I'm wondering is this more of a case where the government says this is the need we need fulfilled, and asks industry to come up with solutions, or do you all develop ideas and products and like, I'm curious to sort of how that relationship works.
It's definitely a mix of both. So, a lot of what GVSC does is they're working with the PMs who are coming up with requirements for these different programs, or working with the soldiers directly. They're trying to figure out what needs there are. And they often go out to industry like us and, other companies to try to do, research and development to meet those new emerging requirements. At the same time, I'm sure Kevin would echo that if there are things available in the commercial industry that they can leverage, that is also of interest, because the commercial industry, particularly automotive, is spending billions of dollars, and being able to leverage that technology is also important. So we do obviously make products and try to see where those can be leveraged for the defense side as well.
Right, that makes sense. And Kevin, I'm curious if you can talk about to what extent some of these technologies are actually being used now, or is it mostly things are still in the testing phase? I think we're so used to sort of where we are with, passenger vehicles, that it's interesting to compare where we are with national security technology.
Sure. So from a ground vehicle perspective, there are no fielded autonomous systems in mass. Where we are really is in the stage of experimental prototyping. There's we have 60 vehicles down at Fort Polk, PLS leader follower vehicles that have been down there for about 18 months, and looks like they'll down there for the foreseeable future, to really focus on a couple things. One is evaluating the technology, what it does well, and where there's still deficiencies. We know we're just on the nascent front edge of this type of capability, and it's only going to improve over time. But also at the same time, the Army isn't used to fighting unmanned vehicles. So you don't just bring in a new capability and the Army automatically knows what to do with it. So part of this process is really educating the warfighter and the folks who write the requirements of what's possible, what are the strengths of these systems, what are the limitations, how can you use techniques, tactics, and procedures, TTPs, we love our acronyms, to mitigate some of the drawbacks of these systems while maximizing where they do things very, very well. And that process, it's always great to have the best technology, and almost in all cases, the U.S. has had that luxury for a long time, but it's how do you use the technology and fight with it most effectively? There's been many examples through history where it's not always the best technology that wins. It's the folks that use the technology that they have and employ it properly. Back from World War II to night vision goggles, the art of fighting the war is critical, and this is a sea change for how the Army does business. And so getting that piece right is why experimentation is so critical. We also have on the robotic combat vehicle side a continuous drumbeat of experimentation, maybe not as long and deliberate as some of the sustainment efforts or the convoy efforts that we have, but we're building up to that. So we've had an experiment last year at Fort Carson for 8 weeks. Where we had 4 RCVs and 2 control vehicles that fought alongside manned vehicles and went against force-on-force engagements. Next year we'll have 12 robotic combat vehicles with 6 control vehicles, so a company-sized element going through and doing another 10-week experiment. So I think the buildup is more than likely in the future we'll have an RCV, a robotic combat vehicle experiment very similar to what we have going on at Fort Polk now, which is this continuous soldier using this equipment. Maybe it's not ready to go to field, wide deployment, but the only way we're going to get smart and understand, what the true requirements are for this capability is to use it and get it employed with soldiers giving us feedback. These are software-defined systems, so making changes is not, it's not a 7-year acquisition cycle. This is, we're putting the processes in place for how do we take feedback, make the updates, flash it to the trucks, get the safety approvals, and then, within a matter of months, have that capability deployed on trucks to the very soldiers that gave the feedback. We're seeing that being done at Fort Polk, and that's a model that we think is going to be the future model for how the Army fights and competes with a rapidly adapting adversary, and always changing conditions.
Right. I'm curious if you could talk a little bit more about the testing at Fort Carson last year with the unmanned combat vehicles. Are you able to say sort of what were the lessons learned, like what were, what was expected or unexpected, kind of what were the takeaways from that?
So we were using M113s, which is, if you're familiar with military platforms, is it really came out of the Vietnam War. It's an ancient platform, but we converted it into a robot. And the reason for just as cheaply as possible, how can we get something that's representative of what an RCV, a tracked platform, might be? We were able to effectively show that the warfighter said, gave us the feedback that, they would use this if it was available to them. And it really gave confidence to our cross-functional team, which is the next generation combat vehicle cross-functional team, or CFT, which really derives this requirement space. It gave them the confidence that this, this is something the Army should pursue and push forward with. Not, this isn't a one-off, let's wait 10 years and try it again. This is no, we are going to continuously move forward in this space. It gave lots of practical feedback on things like autonomy, teleoperation, the warfighter interface, what they liked, what they didn't like, that becomes invaluable for us. So that focuses us on what we develop. So the next time they see vehicles come, next year, they can give us a new round of feedback, and hopefully we've mitigated all those concerns they had last time. And that through that process, and we want to shorten that duration as much as possible, is how we come up with the next generation of capability, as opposed to like what it was in the past, which is like this exquisite requirement that like you project what you think you need in 10 years, and you're invariably wrong. And you do all this work to try to get there, and then you realize 7 years into it that you're not going to do what you thought you did, or you don't need what you thought you did, and you have to start over. That process is industrial age thinking. We can't, we have to move. And luckily Congress and the OSD, or Office of the Secretary of Defense, is really encouraging folks to modernize, acquisition processes to modernize. And I think the ground vehicle robotics is really one of the points of light that is hopefully going to show how we can do this as an Army across a whole fleet of vehicles.
Absolutely. And I'm curious if you can talk a little bit more about the technology. When people register, they send in questions, and a lot of the questions we got were sort of comparing the technologies being used in the defense sphere to commercial applications. One of which is, the passenger vehicles and other vehicles on roads use a lot of markings, like, road markings and things. When you have a defense vehicle that isn't on a roadway necessarily, that may be operated, how does it localize? What is it?
Yeah, that's a great question. So the commercial market, like you mentioned, they have a lot of things that they can kind of rely upon, having one or more of these, right? Mm-hmm. Good access to GPS, maybe even subscription or a base station, things like that, to get pretty high accuracy GPS data. Things like lane markings that delineate the road that you are trying to follow at this time. And also kind of HC mapping, right? So a lot of people will go out and they will collect, even manually drive through neighborhoods, and they will adjust all the maps and get them to look nice and pretty, so that the next time that they drive through this area, they can basically localize themselves relative to all the different features that are in the environment. Mm-hmm. On the military side, we can't rely upon having really any of those. So we have to, do things a little bit more smartly, and be able to do things live on the fly, which is definitely a challenge that we've been working on for a lot of years. So we've developed, as I mentioned before, a lot of localization products. So we have a GPS INS unit that we've built in-house specifically for ground vehicles and robotics. So that kind of gives you a good base of having a good kind of relative localization solution, we call it. So over short periods of time, it's very accurate, but over long distances, just by definition, your inertial system is going to drift. So you need some type of absolute where am I in the world updates in order to kind of have a good idea of where you are. So a lot of people say, well, you got GPS, but we're driving under tree canopies, or maybe somebody's purposely trying to jam GPS. We can't rely upon that. So we do, we call it registration or SLAM. It's similar to what the commercial side does with the HD mapping, but we have to do everything live on the fly. So if you have a team of vehicles, let's say like a convoy, that lead vehicle is constantly taking sensor data that it has, whether it's LiDAR data or camera data, and looking for features and sending back those feature information to all the other vehicles in the convoy. So even if they can't know exactly where they are on the earth, according to GPS, they can know very accurately where they are relative to where that, and really that's the important part for convoys. And we do a lot of similar things for that for kind of subterranean environments as well, because we may not ever have GPS there. So having basically a shared world model that all the vehicles in a distributed manner can try to use all the information they have to the best of their ability to match what they see and what all the other vehicles see, and use that to estimate their position. It's kind of the high level overview of how a lot of military systems are working.
And then Kevin, another question that comes up similarly is when we are talking about passenger vehicles, people ask about cybersecurity, and obviously that would be a huge concern for the military. Can you talk about how you address cybersecurity concerns, or what lessons you've learned that would be applicable to to civilian vehicles?
Well, I think it's leveraging a lot of the similar approaches that civilian vehicles are taking. We used to talk about in the military, talk about the survivability onion, where you have layers of protection from not being detected to not being, not being targeted to not being penetrated to not being destroyed. Like across, there's really a cyber onion too. And it's the layers of how do you layer the redundancies and protection systems and close off vulnerabilities to the best of your ability, and you're never going to be perfect. But how do you, don't give someone access. If they get access, don't allow them to get after critical systems. If they get access to critical systems, know that they're doing it so you can, actively go back, all the way down to how do you, if you're being attacked, turn the attack back on them and attack whoever is attacking you. these levels is really fundamental to how we're built in. And just like the DoD can't drive investment in this space, commercial industries, there's obviously, watch the news, there's a lot of there's impetus now that it's not just folks aren't just going after military actors, they're going after from a resourcing perspective, going after the cash cow and ransomware and all that sort of stuff. So how do we take advantage of systems that are in place that just think of how do we update software over the air the same way some automotive companies do? How do you apply that now to the military space? Because I can tell you, just with the 60 trucks, flashing new software manually to each vehicle is a very time-consuming process, and then validating that it works. That's something that's sustainable with 60, but not with 60,000. And so being able to take advantage of commercial standards that are out there, commercial products that are out there in those spaces, and then applying them to our systems, really all the way down from inside the autonomy, and then building your way back out to the communications and the attack vectors from like maintenance ports and those sorts of things. It's a holistic strategy, and it's one that we're never going to finish. It's really a cat and mouse game of how do you continue to update and secure your system while other folks learn how to degrade that capability.
Right, absolutely. And Anne, I'm curious, when we talk about, again, on the civilian side, that AV technology could help improve safety and mobility and sustainability and all these different things, you all talked about safety, obviously, particularly in combat vehicles. What are some other advantages you see of AV technology in the defense space?
So there are a lot of things that robotics can do better than humans. There's obviously things humans can currently do better than robotics, but I'll give you one example. So we are working on another project with the Ground Vehicle Systems Center related to the convoy project, where we are trying to reverse with doubly articulated trailers. So if you imagine just you and you rent a trailer and you're trying to reverse, it's hard, but you can learn how to do it. You're probably not reversing for long distances. The military trailers that they use have an extra degree of freedom. So normally, there's this pin that can hold that in place. So you can try to back kind of like it's a normal trailer, and the human has to go and line everything up, and it takes a long time. So they really just want to not even have this pin. They always want to have this extra degree of freedom in there. And basically, you can't do that right now, because a human, even their master drivers, can maybe drive for 2 feet in a straight back line before it just jackknifes, and they can't. So they have to use the pin. But if you have an entirely unmanned system, you don't have anybody that's going to go push that pin in. So right now, a thing that robotics is really good at, for example, is being able to detect those angles of those trailers and write a control algorithm that will use that feedback to know exactly how to command the truck in order to get that trailer to go exactly where you want it. And we've been able to demonstrate reversing around 90-degree turns, going a kilometer backwards without the trailer or without the pin in the trailer. And we literally had some of our Fort Polk soldiers that have been testing the system tell me that seeing that made their entire Army career. They didn't believe that it was possible to do that, because it's not possible for a human to do that. So that kind of technology is things that is kind of low-hanging fruit for robotics. We can give this aid to the soldiers and make their lives a little bit easier for things like that.
That's fascinating.
And Tara, I can add to that too. Besides the capability the autonomy has, it also frees up a lot of vehicle design. So there's a huge element of vehicles are large in the military because they have to protect the people inside them. And if you no longer have to protect those people, you can start doing a lot of things with vehicle design. You can see that in the commercial market with like skateboard platforms. When you start taking the drive line out of it. It's very similar to take that protected volume out. Now you can have a lot of lethality on a much lighter vehicle. You can do things like if you remove the cab from a missile truck, now you can add more missile and drop the weight of the overall system without having to redesign the vehicle. So those are some of the things I think from the vehicle design perspective where autonomy is very attractive in the military, because weight is not our friend. Bridges, being able to go across different types of terrain. The lighter you are, the more mobile you are, the more expeditionary you are. And we we don't just defend our borders, we also have to go places when we fight wars all the time, which is great because we don't want to have to fight here. But weight is your enemy in that perspective.
Absolutely. Well, that is fascinating. We are unfortunately out of time, but this has been a fascinating conversation to look at the amazing stuff happening in the defense space and how the lessons we can learn on the civilian side. So thank you both so much for your time and for joining us today. And thank you to our audience for joining us for our panel this week. Look forward to the next 2 weeks when we're talking about construction and mining and agriculture and how they're using AV technology. Hope to see you next week. And thank you again to our guests. Take care.
Thank you.
Take care.